All right, so this is 300, correct? I got the right class? That'd be funny if I was bragging about being prepared and then it's like, this totally isn't the class. Can we see this fine? Or you want front lights off? Glad everybody answered so quickly. All right, so all of you know me. This is my cell phone, 262-353-6205. Yeah, see, he didn't even wait for people to answer. Like, I can't see because I sit in the back when I'm blind. Best way to reach me is text, followed by email. You can call my cell phone if you want. I probably won't answer. The only person I pick up for is my wife because she knows to only call if it's an emergency. I also ignore my mom. I taught her how to text. So now when she needs me, she texts and says, "Can you call me?" So text me at this phone number, email me here. Those are the best ways to get a hold of me. I'll probably reply within 5 minutes. If I don't reply to an email within an hour, send it again, because that means it got bumped down my inbox. I get a lot of email. You know when we meet. This class is on data structures, so it's the continuation of the 250 course. So we just keep going. We started talking about data structures a little bit at the end of last semester. I'm going to kind of rehash that. And then we'll just pick up from where we left off. Textbook, it's the one you got in the 150 class. I may or may not use it. But it actually is a good text. The concept behind it is it's an overview of each course you have. So there's kind of a chapter for each concept in computer science. So officially, that's a textbook for every single class you have here, so don't throw it out. I'm sure all of you bought it, right? It's like, I gave it away as a stocking stuffer. Oh, funny stocking stuffer story. So my wife got, we put stockings up for our cats. Except Gracie has a Jew stocking because she's Jewish. Seriously, I think we put pictures up on Facebook. It's a blue stocking with a Star of David on it. She also has a Jew mouse. No, hold on. I am covering my bases for offending all religions. Anyways, so she got them all cat toys. Well, cat toys have, a lot of times they have catnip in them, right? Well, one of the bags must have been leaking or something like that. So the cats caught wind of cat toys prior to Christmas. Ripped the stockings to shreds. Yeah, it was funny, actually.
Is it kosher? Like catnip?
Catnip? I don't know if it's kosher. Probably. Let's just assume yes. For a lot of you know that I was born Jewish. Most of my family, my dad's one of 7 brothers. They're all like Orthodox and stuff. Like they all practice their professions like in the garb. So for Christmas, because I'm a jerk, I send them all packages of bacon. True story. That's like the best way to convert Jews. Just stand outside the synagogue with bacon and just hand it out. A couple of them will take a bite and they're like, "Oh, screw this." The very least, they'll go, what's not Orthodox, Reformed. They'll go Reformed. Yeah, the Reformed Jewish church allows you to eat bacon. It's like fake. It's garbage. All right. Objectives, blah, blah, blah. Here's your breakdown of your grades. Homework assignments, 45% of your grade. Quizzes, 15% of your grade. There'll be a midterm in here, 20%. Final in here, 20%. This semester, all your quizzes will show up on Angel recorded, so you'll know what you're getting in them. Most of them will just be zeros, so just assume. What's a fair assumption, right? All quizzes will be pop quizzes. I'll never announce a quiz because usually I do a quiz when I feel like it when I get here. Or if I'm running 3 minutes late, then I give a quiz while I'm setting up. So it's a good way to seem like you're prepared. That orange juice is not good. All right, so standard grading scale, 90, 80, 70, 60. Top and bottom 2% are pluses and minuses. Blah, blah, blah. Questions, comments, concerns, bribes. All right, so that's the course. Something new this semester is, and this is already up here under lessons, there's this document called Homework Directions and Self-Assessment Template. An issue we had last semester that I ran into at the end when I was catching up on grading was if you couldn't figure out how to do an assignment, you ended up not turning in the assignment. Well, I have no opportunity to give you partial credit in that particular instance. So, this document tells you information about what is required when you turn in homework. So, for instance, any papers you may or may not have, I wouldn't expect to have many papers in here. You'd have mostly programming assignments, but they need to be in either PDF, Doc, or DocX. Chances are I can open some other formats, but put the papers in one of those 3 formats. That way I don't have to email you saying, I couldn't open this, please resubmit it. Saves all of us some time. If you are doing a programming assignment, so in here we're going to be using Java, never, ever, ever submit a .java file as your assignment, as your solution. Angel is written in Java and for some reason thinks all .java files are executables and will not let me open them. So either change them all to .text, or the easier way is just zip up your folder that has all your code in it, submit the folder, submit the .zip folder, okay? So that would be the most convenient for you. You don't have to do anything else special. Finally, for every assignment you turn in, whether it's a paper or a programming assignment, you know how there's the little box, the text box that you can fill in information in? Paste these 4 questions into that text box and answer them. So, for instance, the first one is, which parts of the assignment were you not able to complete fully? For each, explain why you were unable to complete the part and what steps you took to attempt to complete it. I'm looking for your mindset that you went through for trying to solve that part of the assignment so I can try to award some partial credit. Make sense? Okay, so this is your opportunity to replace code with an excuse. And if I believe the excuse, then you might get some partial credit. If I don't, put something funny in there so I at least get a chuckle. You might also get partial credit. Okay, so then I ask you some other self-assessment stuff, like what would you give yourself in this assignment? I've also found that students are almost always harsher on themselves than the teachers are. It's funny.
So does that mean that every single one you put in, we'll just get it?
Well, no, I mean, I'm only going to take this stuff partially into. What I want you to do is sometimes this is a wake-up call for people. When they fill this out and they turn it in, they're like, okay, well, I spent 9 minutes in this assignment and didn't do 3/4 of it. What do I really deserve? Maybe next time you'll work a little harder in your assignment. I mean, I'll make fun of you in class anyways, but you get what I'm saying. So do this for every single assignment so I have some opportunity to give you some partial credit when you don't do your homework. All right? Questions about that? All right, and the first assignment is already up. I'm sure all of you did it because it was due today, right? I will push that off and make it due on Tuesday. I actually thought about emailing everybody when they canceled class saying, don't forget to do your homework, but figure I won't be a jerk. So this is kind of a review assignment, just to kind of get you back into the speed of programming, because I'm sure all of you spent most of your break programming, right? You know, you had to keep up, keep your skills sharp, right? I'm friends with you on Facebook. You were not programming. You were not programming.
Did you get the car working?
Not yet.
Am I friends with you on Facebook? Are you on Facebook? Heathen. The Amish Facebook, they all just share a tree. Every couple of weeks, they switch trees up because they start running out of real estate to carve. Oh, so good. All right. So, any questions about the course at all? Blah, blah, blah. All right. So, let's kind of pick up where we left off. Kind of revisit this slide when we're talking about data structure. So most of this course deals with this concept of a data structure. So think of it as advanced computer programming or whatever, but really what we're doing really what we did in the last course is we learned the basics of computer programming from the perspective of what does the language provide for us. So now we have a toolbox filled with a bunch of crap that we can use to solve kind of a general classification of problems. Well, some problems are inconvenient to solve because we haven't built more complex structures out of the simple tools that we have. All right, so what is a data structure? Well, it's a structure for holding data. Fine. So think of objects like a super variable, where we can store more than one value and potentially do more. So that was kind of, if you think back to the very beginning of last semester, and we talked about there are two different kinds of variables, right? We have primitive types and we have object types. What's a primitive type variable? We all do mind wipes. What's a primitive type? Go ahead. And only hold a value. Okay, so it's a variable built into the language that can only hold a value. That's the extent of its talent. See, teamwork. Teamwork. What was I going to say? Oh, interesting story from break. This actually, the teamwork thing just reminded me of that. How many of you know the comedian Yakov Smirnoff? She's in the right age group. He was my favorite comedian when I was a kid. Kind of during Cold War times. He was a Russian comedian that came over to the United States. He became a citizen, and his last name is Smirnoff, and his whole bit is about how great the United States is. He gets off the plane, he sees a giant sign, Smirnoff for vodka. He's like, "Oh, what a country!" They're like welcoming him here. Well, when I was down in Florida over break visiting my grandparents, he did a show at their retirement community thing. And it was actually a really good show, but it brought back childhood memories of all these like funny jokes. We don't have comedians like that anymore. Like guys who can actually be clean comedians but hilarious. He has this bit like, I get off the plane and, one of my friends, he invites me out to his farm. Plays a practical joke on me. He says, "Would you like to milk my bull?" I tell you, milk this animal once. You have a friend for life. So, it's got some innuendo in there, but he's talking about the difference between healthcare in the United States versus Russia. In Russia, we don't waste any time with tests and all this stuff, nickel and diming you. We go right to autopsy. And police in the United States, they introduce something new to me I'm not used to. It's called the warning shot. So, anyways, one of his things he says is, he talks about teamwork, and so when I said that, I said it in my head in kind of a Russian accent. It was funny. All right, so two types of variables, primitive types, built into language, could only hold a value. Then we have our other type of variable, which are objects. What we dealt with in terms of objects last semester was kind of writing simple little objects for holding multiple pieces of information, right? Remind me, did we do anything like with playing cards or anything like that last semester? Tell me what we did with objects last semester. Don't all speak at once. What were some of your assignments last semester near the end? Okay, and so you created a dice object, right? Okay, the dice object probably kept a couple pieces of information, like number of sides and quantity. Okay, so we had a single variable, single object called dice, and we could build that object giving it two pieces of information, and we can extrapolate and say we could have it store 30 pieces of information if we wanted, right? But we built the dice saying, this is how many sides you have, this is how many dice you represent. Then we probably gave it a method called roll. Right? And the roll method would roll that many sided die that many times. So we built all the details inside of it, right? Now let's go back even farther. So probably the beginning of last semester when we talked about how there are three different kinds of programming languages. Remember all those slides? Okay. And two of the languages we compared were procedural languages and object-oriented languages, right? So I think I probably used the example of the telephone over here on the desk, where the procedural version of a telephone is a pile of wires that are all hooked together in all the right ways that it technically is a telephone. If you fished through there and found all the, the handset and the buttons and crap, you could probably make a phone call. The object-oriented version of that would be something that we would look at and say, hey, that's a phone. We know all the wires are inside there, right? But we don't need to deal with those wires on a daily basis. We only need the public interfaces of the phone. We need the handset, we need the buttons, that kind of crap. Okay? So, when we think about data structures, we want to think about doing things in objects, hiding all the details, because the details are there. All of us have these cell phones. We know there's a bunch of really cool, hard to implement stuff inside of these little square boxes, right? Or rectangular or whatever. But very few of us actually break it open and start looking in there for the details, unless our phone breaks, and then we have nothing to lose, right? So we want to start thinking about objects even more this semester. But instead of objects that solve problems like dice and things like that, which is a very specific problem, the concept of data structures really focuses on solving generalistic problems that allow us to solve other problems. So kind of a stepping stone. So kind of like if we have some Legos, building a bigger structure that we then use as part of a new building block for maybe building castles or something like that. All right, so we're going to be dealing a lot with objects this semester. And let me go back here for a second. Tell me about arrays. What are these guys? We're here. We'll sweeten the deal. Arrays versus strings. I want to know what both of these are now.
Is that sweetening the deal?
I was going to ask about strings anyway, so I might as well connect the dots right now. Besides, I have to enjoy my coffee.
Still got the shakes going on.
Oh yeah, they're worse than ever. I started getting like these shots for them. My neurologist, I have to go in, at first it was once a week, now it's once a month because I've like built up or whatever. It's a needle that's about that long. It's the most terrifying thing ever. And they put it back behind my shoulder on this arm, the arm that I have my tremors, and they inject it into your bone. And it's not doing crap. It's supposed to make my hand stop shaking, and it doesn't do anything.
So why do you keep getting them?
Well, he says, well, sometimes it takes some time, but that's what they all say, so they can keep getting their copays.
Yeah, exactly.
But it actually is kind of awesome, because like you think it's going to hurt horribly bad. It really doesn't hurt that bad. Like it feels like a whole bunch of pressure, like somebody's pushing, and then there's a really sharp pain for like a tenth of a second, and then it's nothing. But it basically looks like somebody stabbing you with a sword. Oh yeah, so where did I get on? Oh, you asked me about my shakes. Yeah, whenever any cup of coffee I put in my left hand, I only fill about 2/3 of the way because I'm gonna bound to spill it all over my hand. All right, you're changing the subject. Arrays versus strings. What are arrays? What are these guys? What do we use them for?
Holding multiple pieces of information.
Okay, holding multiple pieces of information under a single variable name, right? Okay, what's a string? Go ahead.
Variable that holds a string of text. Well, a lot.
Okay. Would you say that a string holds multiple characters under a single variable name? If we're trying to line it up close to what arrays are. So arrays hold a collection of like type values under a single variable name. Strings hold a collection of characters under a single variable name. So they're very similar in that respect, right? Except strings only hold chars. Arrays can hold chars or hold ints or booleans or whatever we want, as long as they're all the same kind of value. Okay. What are some limitations of strings? And by the way, most of your first review homework assignment deals with manipulating strings. So this would be beneficial, even though I'm sure all of you have already done the assignment, right? What are some limitations that you remember about strings? So, as a reminder, last semester we wrote a bunch of different string manipulation methods, right? One of those methods was something like remove vowels, right? Remember that one? Where you took in a string and you were supposed to spit out a string that had all the vowels from the string that you took in removed. How did you implement that? We had to start with a brand new string, didn't we? And instead of removing vowels, we kept non-vowels. Remember that? Okay, why did we have to do that? Why couldn't we just go through our string and remove all the things that were vowels?
Strings cannot be changed. They can
Yeah. Strings are not in programming speak, so you can sound smart. Strings are not mutable. What a stupid word, right? Mutable means changeable. Why don't they just say changeable? Just dumb. It's dumb. So strings are not changeable. So if we need to add or remove something from a string, we need to build a brand new string. Now, for those of you who are Java geeks and maybe were exposed to Java before this class or have done some reading on your own, you've maybe seen people use a class called string buffer. Any of you ever seen that? Okay, so string buffer is just a wrapper class that allows you to change a string. I promise you, under the hood, they're building a brand new string. They're just pretending like you don't have to do it. They've just automated that for you. So strings are read-only. If you want to change a string, you have to build a brand new string and keep the stuff you want. Don't keep the stuff you don't want. All right? So that's a limitation of strings, correct? All right. What's the benefit of strings, though? This has to do with the benefit of almost all objects. Remember, objects can hold 0 or more values. There's no requirement that an object has to hold a value. But typically when we think about objects, we think about them being super variables and that they can hold 10 values, but they can potentially do more. What's that more stuff? What makes up an object? What are the 3 things that are members of an object? So we have the name of our object, opening curly brace, closing curly brace at the bottom, and in between, inside the sandwich, we have a collection of stuff. What are the 3 different types of stuff that are in there? One of them is field. What's a field?
Place where the Amish grow their corn.
that's extra credit. Man, what if the dean watched this class? Actually, he knows me pretty well. He'd probably just
Laugh.
yeah. He knows I'm harmless-ish. Harmless-ish. Okay, other than where the Amish grow their corn, what is a field? What is a field as it relates to objects? It's a variable. And that's true. It's global to that instance of the object. So that's accurate. So a field is the special term for a variable within an object. Fine. What else? So we have fields. We have two more things, 2 more members of an object. So I'll create a slide for this so we have objects have fields, which are variables. Methods. What are methods?
Collection of code that can run multiple times.
Reusable chunks of code. I love the word chunks. Just sounds so inappropriate. See, you guys had to come to my class to get some entertainment, right? Beginning of semester is always so boring. What else? We have a third guy that goes inside of objects, kind of like methods. Constructors. Okay. What's a constructor? It's the lead Amish guy in charge of barns.
Real estate agent.
The real estate agent is involved with calling a constructor, but that's not what a constructor is. Oh, just so you know, from last semester, remember he had given us the video of the. I didn't even look at his final. Just give him an A, just for future reference. I did look at this final. Not very hard though. I love that video. So what's a constructor? It's method-like, but it doesn't have a return value, right? Why does it not have a return value? It's related to this real estate agent thing. They always return memory addresses. So since it always returns a memory address, we are not going to have a return value. That's especially true since we have no way of saying we're going to return a memory address in Java because, of course, pointers don't exist, right? So what is the job of a constructor? Why do they exist? Why do we have them? The name kind of tells us everything we need to know.
Initialize an object.
Initialize an object. Their job is to construct the object and initialize all the variables or whatever to their beginning state, making the object ready to use. So in real life, we think about if you hire a constructor to build your house, at the end of it, you expect to have an empty house that works, that you can now go and manipulate, put your crap in and stuff like that, right? So constructors build and initialize an object in terms of its fields, etc. That's just what you put for the catch-all, right? Okay, make sense? So these are the things that go inside of objects. Now, again, last semester we built a dice object. And in that dice object we had probably at least two fields. One field was num sides, another field was quantity. So when we called the constructor for that dice object, we passed it the number of sides that this particular dice will have and how many dice we wanted this object to represent. And that constructor initialized those two fields to those values. Then we had a method. We probably had a couple of methods. One was we probably had a display method, but one of the methods we had was a roll method. And the roll method was a reusable chunk of code that rolled a however many sided die quantity number of times and returned that sum. Returned all those rolls summed together, right? Okay, so that's kind of a working example of how objects function. All right, now back to data structures. We built that dice object very specifically for solving the dice problem. Well, computer programming, we're solving a broad classification of problems. And there are some intermediate data structures that we can build. They're actually built into most languages now, but we don't know that. I'm not going to show you that until after we've gone through the hell of building them ourselves. Because it's funny. So, in any case, there are some intermediate data structures that would benefit us to build for solving more complex problems. Now we're back to arrays versus strings. So, strings have the limitation of not being mutable, not being changeable, but they also have a whole bunch of magic tricks they know how to do. They have methods associated with them that allow us to do cool things. For instance, we can quickly have a string convert itself to all uppercase. Well, return an uppercase version of itself. It doesn't actually change the string, but it returns an uppercase version of itself, right? So, as an example, if I say string s is equal to hello, and then I say s.to uppercase, and store the result inside of a string name S2, S2 will hold the uppercase version of hello, capital H-E-L-L-O. S will still hold all lowercase. Make sense? But this is built into strings. So strings can give us the uppercase version of themselves. They can give us the lowercase version of themselves, so on and so forth. Okay? They can give us a character at a particular index. They can give us the index of a particular character. What is two uppercase in this case? Tell me everything you know about two uppercase. It's an instance method. So it's a method, and more importantly, it's an instance method. How do you know it's an instance method?
Because it uses the instance of the class.
Okay, because we're using an instance of the class in which the method was defined to call it. We're saying s dot to uppercase. What's s? S is a variable. What are variables? A field is a variable, but not all variables are fields. So a variable is only a field if it's found inside of an object that we're creating. If it's a local variable within a method or something, it's just a variable, not a field. So what is a variable? If you had to describe to me what a variable is for, why do variables exist? Go way, way, way back to day one of 250. Probably day one of 200, actually, when we talked about, the way human beings solve problems, right? We use our memory, we ask questions, and repetition. Memory is simulated in a programming language using variables. So what's a variable? Yeah, so it's a named storage location in memory for us to store a value. Okay, that's what a variable is. So S is a variable, which means S is the name of the variable, and it points to something in memory that holds an actual value. What kind of value does S hold? In this case, it holds a memory address. And that memory address points to the actual string that's in memory. Right? Okay. What's an array? You already told me it's a collection of like type values stored under a single variable name, right? So tell me more. How many magic tricks does an array know how to do? As far as we've learned. One. What's that magic trick? Or what's that method? Length. An array can report to us its length. That's actually a very important upgrade for arrays. Historically, and I probably showed this last semester, but I'll show it again since it seems like you haven't retained anything. Historically, that's a Helloworld program in Java, correct? What's this crap for? Something to do with command line something. All right. Command line arguments. So what I'm going to do here is I'm going to say vi blah.java. We're going to write a quick little Java program here. All right, so here's our quick little Java program. And that's what it does. It prints out hello world right now, right? So this whole thing I just did here, javac blah.java, then java blah, that's equivalent to hitting the play button in Eclipse. So that's what Eclipse is doing for you. We did this last semester, didn't we? So you should appreciate what Eclipse does for you. Eclipse works like a DVD player. Historically, I would have said it works like a VCR, but none of us know what that is anymore. How many of you have used a VCR? Probably most of us, right? But most of us, when we were young, we've had DVD players or better most of our lives, right? How many of you have ever used an 8-track? Cassette player. What about cassette player?
Oh, yeah.
Like cassette players, 8 tracks,
I've seen 8 tracks.
record player. You're like my age. You've used an
No,
8-track.
I'm older than you.
Right, you've used an 8-track. What are you, like 60?
No. No.
Hey, I just had a birthday.
Yeah, I know.
36 on Monday, first day of school. What kind of crap is that? Happy birthday.
Happy birthday.
Happy birthday, come back to school for your first day. And my wife was on like death's door, so I didn't even go out for my birthday. She just started going, she just went back to work today.
I know that they were horrible because they were even worse than cassettes because they were huge and then you had to like plug them in to a...
Yeah, it was kind of like an Atari 2600.
They are horrible. I had one.
How many of you ever used an Atari?
Yes. That was my first.
I had an Atari 4800, which is actually older than the 2600. It's an older machine. It was weird. The 2600 was like the awesome Atari. I one time got what I believe was the high score in Joust on Atari. And there was an old video gamer magazine. So my dad had to come in and he took a Polaroid of my television set with my score on it. We sent it in. I got my name published. Now what are we doing? We're doing live streams of our video games now. I sent in a Polaroid picture of like a black and white TV. Well, that's better than some. Her dad probably remembers whatever came before radio. So, I think it's just people outside making pretend drums with sticks. For the record, my dad is older than her dad, but not by much. I could be one of her dad's. I could be her dad's oldest kid. Right? Your oldest brother's like 33, right?
Yeah.
All right. So, anyways, here's our Hello World program. We got to make sure we offend everybody. That way, you're not. See, I try to be equal opportunity. Is what it is. All right.
Making fun of people. Where's Miss in this class?
Yeah.
I think she's an IT major, so she doesn't have to take this class. You are preaching to the choir. All right, so now let's look at how the command line argument thing works. By the way, you're seeing this is an old-time Unix text editor I'm using, so this is what came... Huh?
Can you at least use Nano and be a civilized human?
Who uses Nano?
Who doesn't use Nano?
Well, first of all, do you even know where Nano came from? Let's go some history here. Okay.
All I know is it's better.
First of all, Nano was never written as a text editor. Nano was the text editor for an email client called Pine. Okay. In the early days, when it was first released as an editor, it was called Pico. PICO. Then they renamed it Nano because it sounded cooler, I guess. It was never meant to be a real text editor. It was meant to allow you to write emails. Now, Vi, this is a text editor. I mean, if you want to save it, you have to hit escape, write. Just saved it. Boom. Who needs a mouse? And a file menu. Come on. See, now I just had to hit I to go back into insert mode so I can type crap. Use Nano like a civilized human being.
You can use text editor. Come on.
Nano is for the Unix geeks who aren't Unix geeks. Oh man, I seriously almost just typed a whole bunch of keys because my hands started doing the tremor thing on the keyboard. It was funny. Okay, so this command line argument thing, this guy up here, string array args. I'm going to go through. So again, this guy's a string array, so he's an array. And arrays have one magic trick that can tell us their length. What can you tell me about length in this case? What is that guy?
What will that boil down to?
You couldn't tell me what it's going to boil down to. You can tell me the type it's going to boil down to.
Yeah.
Yeah, but it's going to be an int, right? But what is it? What were you... here, back here. Where's my 2 uppercase? Did I do a 2 uppercase somewhere? Oh, whatever. In any case, you told me, Amish told me that this guy, that 2 uppercase was an instance method, right? Okay. What's this guy? And how do you know? That'll be my follow-up question. Cup 1 down.
Probably isn't helping your shakes.
I do decaf. It's decaf. No, a human being probably could not survive on the amount of coffee I drink every single day if they drank caffeinated coffee. I mean, I drink an insane amount of coffee every day. You know, historically, you guys know I was a competitive eater. I can actually drink more liquid than I could ever have eaten. It's ridiculous. I probably drink 2 gallons of coffee a day. Just passively. Just chugging the stuff. Yeah, so caffeine would be dangerous if I drank caffeinated coffee. As it is, hey, look at that. Terrible. See, they don't have that in Amish communities because they're living off the land. They're healthy. Chemical poisoning over here. What is this guy? Args.length. Come on, somebody knows the answer to this. We've already answered the question in class today. Not a method. Why isn't it a method? How do you know this is not a method? No parentheses, no parameter list. If this was a method, we'd have an opening and closing parentheses here at the end of this. Okay, so not a method. If it's not a method, what must it be? Well, it could potentially be 2 other things. Either what or what? Constructor? Is it one of those? Is it a constructor? How do you know? No parentheses, and also this is not how we call constructors. If it was a constructor, we would see the new keyword, the real estate agent, present, right? So not a method, not a constructor, must be a what? Must be a field. What kind of field? Instance field or class field? We're seeing it being used in the wild. So the way we can answer the question whether it's an instance field or a class field is by noticing the way it's being called. It's an instance field. How do you know? We're using an instance of a class to call it rather than a class name itself. We're saying args.length. Okay, so length is an instance field in whatever class the string array class is. Okay, I don't want to get too much into that because arrays are actually special cases in, well, I'm actually going to get into it somewhat here. Arrays are special cases in Java. They're better in Java than they have been historically in other languages. So let me finish showing you this example here. But args.length will boil down to the number of elements that are inside this array. But that doesn't get set until I actually run my program. But at runtime, this loop will go through the number of times that there are elements inside of args. That includes 0 times. So if I just come in here and print out blah, this is going to print out blah some number of times. Okay? How many times? The number of times that the args.length number of times. So I'll go ahead and recompile this. I'll run it. Nothing printed out. Why? I gave it no arguments. Now if I run it again, but I give it 3 arguments, we'll see blah print out 3 times. That make sense? So that args thing allows us to pass inputs into the program itself to kind of get the program started. Okay, what's this doing? That's array syntax, correct? What am I doing there? Args at bucket I does what? It boils down to, go ahead.
Well, it's going to print out the argument, whatever the argument is that it's going to repeat each argument.
Okay, well this whole line prints something out. This guy right here boils down to the argument at bucket I in that array, right? The value that's at bucket I in the array named args. Okay, so this should actually print out my individual arguments rather than just blah 3 times or however many times. So I'll compile this again. So I'll pass it here. I'll pass it 4 arguments, A, B, C, and D, and it'll print out A, B, C, D. Make sense? So that's what those command line arguments are for our programs to take in some input. Less common today because most of our programs are graphic user interface type stuff, and we collect initial stuff usually on that first screen, you know, login information, that kind of stuff. But if you're Caitlin PC,
Yeah, I was wondering why they were saying that.
where'd that come from? I thought it. Well, actually, I know where it comes from, but I thought I had wiped this machine. That's the person. Somebody was borrowing this laptop from me for a while, and that's his ex-girlfriend. I promise you, I formatted this computer. Man, exes, they just never go away. That's kind of creepy. I have to text him after class. I'm almost positive that's what it is. That's just weird. I tried to kill it off, but nope. Oh well. We're just gonna go with it. All right. So makes sense what command line arguments are in Java? Well, remember Java has a grandparent. No, I'm sorry, a parent of C++ and a grandparent of C, older language, right? So let's go ahead and write the equivalent Helloworld program in C. So, you want to use Nano?
Yes.
No. So we'll do hello help dot C. All right, so we're going to write a C program. think that'll be for C. Man, it's been a while. All right. All right. See, I just proved the. Remember, I told you last semester I made you memorize how to write a Hello World program. That is beneficial. So I probably have not written a program in C. I don't know, 15 years, something like that. So here's the C version of this this program. I'll show you the C++ version. We'll go through a little evolution of programming. I've maybe written the C++ version a decade ago. So in any case, in C++ or in C, first thing we had to do is we had to include the standard input-output library to teach us how to write to the screen and not write to the screen. That stuff's built into Java, so that's a convenience we already see in Java, right? We don't have to do anything special to have access to system.out.println. In C, we had to import, include is the same thing as import in Java. We had to include standard io.h in order to get the printf function. Okay? And we printed out hello world followed by a carriage return. Now, notice that main, first of all, returns an int here instead of void. Void you can do in C++. The reason it returns an int is because back when C was created, Unix was where all programs were written. And programs typically had an error code that got returned from them. Did everything go well? Did this program fail because of some error? So they would actually boil down to an int. You know, usually 0 if everything was kosher, or some other error code that you had to then go look up somewhere, like what is error code 1234? You know, that means that there was an IO error or something like that. So that's why main returns a value. Because remember, all programs begin and end with main, right? This is where that comes from. So notice in C, we don't have this thing wrapped inside of a class or anything like that. We have, you know, we literally have just a function here called main. Main takes 2 parameters. First parameter, argc. And what I'm going to do here, actually it might not work. I probably have to, yeah, that'll work. So I'm going to go ahead and print out argc. So this is a placeholder. %d is for a placeholder for a decimal. And then I'm going to fill that in with the value that argc holds. So argc is an int. All right. So we'll go ahead and compile this again. And when you compile it, it creates a executable called a.out. You can then move a.out to, you know, blah.exe or whatever you want to call it. So I'll go ahead and run this, a.out, and I'm going to pass it A, B, and C. 3 command line arguments. What should print out? Print it out 4. See the 4 over here? Why? I gave it 3. Why did it print out 4? 1, 2, 3, 4. Also captures the name of the program as one of the command line arguments. Make sense? Well, I gotta do this. it printed it out. I need to do some carriage returns in here for sanity. So there's our 4 command line arguments. A dot out, A, B, and C. Make sense? Now, the interesting bit here is notice that in Java, main takes in 1 parameter, string array args, because a string array in Java, arrays in Java, can report to us how many elements are in them. In C, they could not. That's why we need 2 parameters. First one is, how many command line arguments were there? The second one is the actual command line arguments. What's highlighted there is a string array. That is an array of character pointers, a pointer to an array of pointers, where each of those array of pointers points to a string. Each element of that array of pointers points to a string. Now I'm going to change this syntax up a little bit to really terrify you, because it's fun. That's not what I was expecting. Still had a cool output. Arg v. Didn't like that. Well, let me tell you what I'm trying to do here, and then we can try to fix it. Remember when we first talked about arrays? This is just so you see it's all connected to what I'm talking about here. Arrays are actually, they must be contiguous in memory. Remember that? What does it mean for an array to be contiguous in memory? So when we create an array, we have to say int array AR is equal to a new int array 10. So go ahead. What were you going to say about being contiguous?
They can't be separated.
Okay, so this guy, this new keyword, that's our real estate agent, right? His job is to go out and find us memory to store this array. What do we need to store? We need to store 10, in this case, 10 of these guys. 10 integers. How big is an int? In Java, how big is an integer? You got one guess and your entire grade for the whole class depends on it. Covered it too many times. Go ahead. 32 bits. Right, the class now has an opportunity to pass. They would have failed if you got that wrong, but you know, no grades have been set in stone at this point because I'm a cheater. So, in any case, what did the new keyword do? It went out and found 10 times 32, so 320 bits of memory in a row inside of memory to hold these integers, right? So AR at bucket 0 is actually at memory address AR, the base address of the array, plus 0 times size of int. Size of int is 32, 0 times 32 is 0, AR, the base address of it, that's where bucket 0 is. Bucket 1 is at AR plus 1 times size of int. 1 times size of int is 32. So let's say the base address of the array is 100. That means the second element in the array, the element at bucket 1, would be at memory address 132. Because memory address 100 to 131 is where the first integer is stored. Does that make sense? That's why they have to be contiguous in memory. So what I'm trying to do here is you can't do this in Java. Why? Because pointers don't exist in Java. Well, I'm actually using pointer math. Rather than using the syntax for giving me a certain bucket, I'm saying, go to my array, argv, add to that whatever element I'm trying to access, times the size of an integer, and give me, the little asterisk here says, give me the value at that position, as opposed to the address. If I don't put the asterisk there, oh, actually, I think I know what the problem is. Well, let me just do this real quick. That's the placeholder for a pointer. So if I don't put the asterisk there, I think I should just get memory addresses, but the pointer might output something different. Yeah, those are memory addresses. So these should be, notice how these kind of walk up at a certain pace? It's showing you contiguous memory. So these are hexadecimal values. So assuming it's 32-bit integers here, this hexadecimal value plus 32 bits should be this value. So on and so forth. Okay? So I should then be able to go back and put in that, which says give me the value at that address. So that's still the pointer. Pointer would be the memory address. So I know that there are strings there. So I think I still need to say S. But that didn't give us what we were interested in. Oh. Pretty good reason why. It's an array of chars. Char pointers, not ints. There's our ABC. So let's go back and look at that, because that's actually an interesting lesson. Of course, I did it on purpose. I always do. It's my brilliance is what I like to bring to the classroom for your learning pleasure. All right. So in Java, we're walking by size of int because I'm storing integers here, right? But really the equivalent would be this if I'm comparing it to what I just wrote in C. So I'm saying create for me an array of strings using the real estate agent to go and find me enough space to store 10 of these guys. Well, what's a string? So this goes back to our arrays versus strings. A string is an array of characters, is it not? Under the hood, it's an array of characters. So the very first character of the string is going to be a char pointer, correct? It's going to point to the first character in that string. So if I was to show a picture of an array of strings, it would look like this. We out at 11:15 or 11:20? So we're good, okay. So it looked like this. So here's AR, and let's just say AR is at position 100 in memory, just to keep the math easy, because I need easy math. All right, and what's that going to connect to? That's going to, well, I want to make sure I keep the boxes the same size. Just for my own sanity, we're going to have a 3-bucket array. So there's my 3 buckets. So AR points to the beginning of this array. Well, this is an array of strings. Well, what's a string? A string is actually a memory address. So each of these guys, let's just say my strings are cat, dog, fish is short enough, I guess. All right. So I have cat, dog, fish. Bucket 0 is going to hold a memory address. So let's just say this is 200 for no good reason. And that guy actually is a pointer to the beginning of this string. And let's say this guy is memory address 631 for no good reason. And that guy is a pointer to the beginning of that string. And this guy is memory address 1312. And he is a pointer to that string. That make sense? So it's a double pointer. The array points to, AR points to the beginning of our array. And each element of this points to the beginning of its string, which is a character array. That make sense? That's why in our program here, this is a char pointer pointer. It's a double pointer. We have a pointer to a pointer, which points to a pointer. Okay, so I'm taking the base address of our array, argv. That is this guy, this base address right here. I'm adding to it whichever bucket we're on. So I times the size of char. And chars in Java are 16 bits. Chars in C actually I think are 8 bits. But whatever. Actually now it's probably 16 bits. They probably support Unicode, but whatever. So we're adding to it whichever bucket we're on. So this is going to boil down to a memory address. Okay, that is, it's going to boil down to the address that's inside of here. Does that make sense? Then, well, this is going to boil down to the address that's inside of there. That whole thing. This boils down to the memory address of this bucket. So this bucket might be at memory address. I know we're basically out of time. Let me just finish this thought. This is 100. This is 104. Just let me, well, 102. Let me go with 16 bits. And this is 104. Okay, these are in jumps in bytes. So 102 would be 16 bits, 2 bytes. All right, so this guy would boil down to memory address. If it was 0, memory address 100, then I'm putting, give me the value at memory address 100, which would be 200, the value in there, which is a pointer. And this says print out the string at that address. That make sense? So that's where it's converting it into its real value, not a memory address. So that's how this is all working. So in C, it becomes kind of more obvious what's actually happening under the hood in Java. We'll come back next time. I'll start off. Somebody remind me that I want to show you the C++ example of that so we can kind of finish this evolution of languages, and we'll go from there. Remember, your first homework assignment is already up on Angel. It is due on Tuesday. I'll change the due date for it right now. And I'll see everybody on Tuesday.